Hey, this is Mr. Beckstrom, and today I want to take a look at an example from number 16 from section 3.2 homework. This is a pretty lengthy problem, and it says find all the real and imaginary zeros for the polynomial function, and it gives us a fourth degree polynomial here. Now looking at this, this is pretty crazy. Now we've learned a lot of different methods, including factoring and the quadratic formula and all kinds of stuff to find the real and imaginary zeros for a second degree polynomial. But once we get past the second degree into third degree and fourth degree, there are so many different ways that you could possibly factor this or have these rational or irrational or even imaginary zeros that just trying to guess at these in factors is nearly impossible. So we have to come up with new ways of kind of using like a process of elimination to break this down into something more manageable. So we're going to introduce the rational root theorem here. And what that says is that if there's any real rational roots, so let's just kind of define that again. A real number means that it's in our real values. It could be rational or irrational. Rational means that it's either repeating or a finite decimal number. That means it can be represented by an integer over an integer. It's not a repeating forever kind of irrational number like pi or e or something like that. And it crosses our x-axis somewhere. If it is one of those real rational roots, then it has to be a factor of the last value here, some factor of 3 over some factor of the first coefficient of 95. We're going to look at those. So we're going to take all the factors of 3 and we're going to call it P over Q here. So if we call P equals all the factors of 3, which are plus and minus 1, that means 1 and negative 1, and plus or minus 3, and then we look at all the factors of Q, which are all the factors of the first coefficient, 95. So what are all the things that go into 95? So we have plus or minus 1, we have plus or minus 5, and that goes in 19 times, so plus or minus 19. And we also have plus or minus 95. And I don't think there are any other roots of that. Let me just double check. All right, so here we go. Okay, so we're going to get our calculator to kind of help us with this. We're going to narrow it down, and then we're going to check. And remember, we know that if we put a possible root in here and we get a 0, then that is a 0 of our function from the zero theorem that we have. So we're going to look at all the possible p's over q's, all the possible p's over q's. So that's going to be, I'll start with this one. So plus or minus 1 over 1, plus or minus 1 over 5, plus or minus 1 over 19, plus or minus 1 over 95. Now what I did here is I just took this value and put it over each one of those. And now I'm going to do the same thing with this value here. So plus or minus 3 over 1, plus or minus 3 over 5, plus or minus 3 over 19, and finally plus or minus 3 over 95. Okay, so that is quite a lot of values there. So the next thing I want to do is I want to go over to my calculator here, and I want to go ahead put this function in my calculator. So I'm going to go to y equals, oops, all right. clear this out, and I'm going to put this function in there. So I have 95 x raised to the 4th power plus, in just a moment, excuse me, that is minus 4x cubed, 4x cubed, that was not a cubed, 4x cubed, and then we have a plus 92x squared plus 92x squared minus 4x minus 4x minus 3, minus 3. All right, so we have a big old function here. We have all of these. Let's count them how many we have. Remember, we have a positive and a negative version for each one of these. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 possible real rational roots of this function. And remember, since it's a 4th degree polynomial, I only have a maximum of 4 roots total. And now remember, those roots can be real or they can be imaginary, and they can also be rational or irrational. So it's possible that they're all either imaginary, which is, if that's the case, we're not going to find any of them here. And it's also possible that they could be all irrational, which, if that's the case, we're not going to find any of them here. So this doesn't guarantee that we're going to find any of them, but if there are any real rational roots, we can find them. So how do we do it from here? Well, I'm going to use my table here. So the first thing I want to do is I want to go to second window. Here's my table set. I want to make sure that my independent, that's my x variable, is on ask, and my dependent variable is in auto. That's my y variable. And then I will go to my table here, and let's go ahead and delete what I have there. And then I want to start putting in these values. And if I get a 0 over here in my y, that means that that's a root of my polynomial. That means that that's where it crosses my x-axis, and that's what I'm looking for. So I have positive 1, and that is not a root because I didn't get a 0. I have a negative 1, not a root. I have 1/5, so 1/5. Oh, that's a root right there. So I'm going to kind of keep that. I'm going to try to find 2 roots because I'm going to try to break this down to a 2nd degree polynomial, because if I can get 2 roots, then we can break it down that far, and then I have other things I can do. And then I have a negative 1/5, so negative 1/5. That is not 1. Let's see what else I have. I have a 1/19. 1/19. Nope, negative 1/19. Nope, I have a 1/95th and a negative 1/95th. All right, so let's try these ones. I have a 3, because a 3 over 1 is 3. Nope, I have a negative 3. No, I was hoping for one of those. I have a 3/5. Now I have a negative 3/5. Now I have a 3/19. And a negative 3/19. Hey, there's my other one. And I have a, so let's write this down. I think I had a, from earlier, I had what, a 1/5. So let me go ahead and make sure. I have a 1/5 and I have a negative 3/19 as 2 of my roots. So I found 2 of them already. Those are 2 of my zeros. And let's go ahead and check the last ones here. Let me go back to, all right, so I just checked the negative 3/19. Now I have a 3 over 95. Nope, and a negative 3 over 95. All right, so I know that my only real rational roots are 1/5 and negative 3/19. So now I can at least use synthetic division in order to reduce this down. I'm going to use the 1/5 first because that's going to be a little bit easier. So what I do is I am going to pull the 1/5 out here, 1/5, and I am going to break this down. So I have 95, negative 4, 92, negative 4, and negative 3. This is crazy. All right. So, using synthetic division, and I'm going to use my calculator for all this since I'm using a fraction. So don't, oops, second quit. Come on, second quit. There we go. So you pull down the 95. I'm going to have to shrink this down a bit. Hold on. All right. So let's go ahead and do it like this. All right, so I've got the 95, and now I do the 1/5 times 95. So that's just 0.2. So 0.2 times 95 is 19. So I put the 19 up here, and then I add that to the negative 4, and I'm going to get 15. And then I'm going to do the 1/5 times 15. That's just going to be 3. 3 plus 92 is 95. And then I'm going to do 1/5 of 95. So 0.2 times 95. And you get 19 again. All right, you add those two together, you're going to get 15. Then you're going to take 1/5 of 15 and you get 3. And you add that and you get 0. And you should always get 0 at the end. If you don't get 0, that means you did something wrong in there. So this is how you use synthetic division. And this means that we can now pull this 1/5 out as a factor. So now I have x minus 1/5 as a factor here. And now my polynomial, oops, and now I have, let me do it like this. Okay, now my polynomial is 1 degree less that is left. So instead of a 4th degree polynomial, it is 95 x cubed plus 15 x squared. Give me just a moment, please. Okay. Plus 95 x plus 15. All right. Whew, that was a pain. All right, so now this is still a 3rd degree polynomial here, but I do have another one that we know. What is the other one? The other one is negative 3/19 that we found. So I'm going to do the same thing, and I am going to use synthetic division on negative 3 over 19 in order to reduce this even farther. So here are my coefficients now. So I have, I'm going to write those coefficients in here, 95. Now remember, if you skip one, if this were to go from like x squared down to x, you'd have to put a 0 in there for the skipped one, but we're not skipping any. So 95 down to 15, down to 95, and 15. All right, so these are my new coefficients there. So the first thing I'm going to do is -3/19 times 95. And here what I'm going to do, so I don't have to type in -3/19. Well, I can do it. It's not a big deal. So just in parentheses, -3/19 times 95. Oh, and don't forget to bring down that 95. So you always bring down the first number first, and then you multiply it by that, which is what I'm doing right here. And I get -15. So I bring that up here, and then I add those, and I get 0. Now this times 0 is 0. Very nice. I add those up, and I get 95. Now this times 95, I already did that one. That gives me -15. And I add those up and I get 0. So let me go out here. So when I pull this factor out now, so I already have this first factor. So now let me kind of go back up here. So I have the first factor of x minus 1/5. I have the second factor of x plus 3/19. Remember, the factors are always going to be the opposite sign of the actual roots there, because when you solve for them, you have to subtract them, right, to get them on the other side of the equality sign. So if this is negative, the factor will be positive and vice versa. And then we're left with, what are we left with? We are left with 95 x squared, and there's no x term, and it's just plus 95. And remember, this whole thing is equal to 0. This whole thing is equal to 0. I probably should have put that for this one as well. All right, so, and really that's all we did with this first one, is set that equal to 0 in order to find all the zeros of the function. So now we found 2 of the roots, and we factored those roots out. So all we're left is this one. So let's go ahead and set that one equal to 0. Now we could use the quadratic formula at this point, or we could do a lot of things, but I'm going to go ahead and set that root equal to 0. The first thing I notice is that it has a common factor of 95. So I'm going to go ahead and pull that out. So 95 x squared plus 1 is equal to 0. So I can just set this by itself equal to 0. So x squared plus 1 is equal to 0 because it's its own factor. Now I am going to subtract 1 from both sides. So x squared is equal to -1. Take the square root of both sides, and I'm going to get x is equal to plus or minus the square root of -1, which that's all that is equal to, is plus or minus I. Remember, the square root of -1 is equal to I. So this was a crazy long problem. I didn't realize it was on there, but kudos to you if you were able to get that. If you tried on it and you just couldn't make it all the way through, let me know, because it is a little bit longer than I had expected. But so the roots, or the zeros, which roots and zeros are the same thing, of the function are 1/5, -3/19, I, and -I. Those are the 4 roots. Remember, if they're asking for all the real and imaginary, you should always have the number of zeros or roots equal to the number of the highest exponent you have if you're talking about a polynomial. All right, so that is this one. If you have questions, which I hope you do, because this was a complicated one, let me know, and I hope you have a great rest of your week. Thanks.